So one important thing to say at the start is that arrays in Java and most other programming languages start with index of 0. And what this means is the first number in the array will be at position 0, the second number will be at position 1, and so on. Since we said an array is a data structure that holds a bunch of data. You can see here, array will have a bunch of integers or a bunch of something. So basically, that's what an array is. And now let's see how to create one in Java. So let's go ahead and create a new file here, main. And I'm going to close all other tabs. Okay, there we go. Let's add the main. And now basically how you declare an array is similar to how you used to declare normal variables. You just type the type of the variable that you want. You put these square brackets to indicate that this is not a single integer variable, but it's an array of integer variables. And you just say equals to new int array. Okay, so this is the syntax that you can see here. New something, this is going to be the array type. So if the type is string, you're going to put string here and so on. So basically the type is int array or string array or boolean array or something array. And then you just say that's equal to this keyword new and then the type again and then array. And here you need to specify how many elements you want. Let's say we wanted 5 or 10 elements. You specify that here inside of the square bracket. That was the error that we had previously to defining the length here. You basically need to tell it, okay, I want you to set aside 5 pieces in memory, which I can store 5 variables into. So how do you actually access a cell of this array? You do array, and then you put the square bracket, and then you put the position in which you want to put a number. So basically, the value here has to be an integer. If I try to put a string, it's going to complain. Why? Because I said this would be a lot of integers. Not any of them cannot be string. They cannot also be doubles. I mean, they can only be integers. So we put into array of 0, we put the value of 100. Let's put array of 1 to be equal to array of 0 plus 5. So, of course, what do we expect to see here? This is now just accessing the value that was stored previously in array of 0. So basically, we're going to say array of 1 equals 100 plus 5, and that's going to be 105. Let's do one more. Array of 3, for example, equals array of 2 minus 5. And now let's put the last one to something. Array of 4, that's going to be the last one, equals 99. Okay. So, or just like array of 3 times array of 1. And let's see what we will get when we print all of them out. So how would we actually go through all of these? Well, you can, of course, manually say array of 0, array of 1, array of 2, array of 3, array of 4. But you can see already that this is going to be done in a much smarter way. We're not going to be having 5 lines of printing. We're going to use a loop, right? But let's first show them like this. And of course, what do we expect to see? Well, array of 0 should be 100. This one should be 105. Array of 2 should be 0 because that's the default value that gets assigned when you don't assign anything. 3 is going to be 0 minus 5. That's a negative 5. And this one is going to be this 105 times, I don't know, 5, which is array of 3, which is minus 525, something like that. That's a good question, Katerina, and let me show you what happens. If you try to do something like array of 5 equals 50, in some languages, you will get an error. In some languages, like C++, old versions of C wouldn't give you an error. They would just allow you to get the value of array of 5 because there is something at that place in memory, you know. So that's a weird thing in C. But here in Java, you get something called an exception. We have seen probably an exception occur here or there throughout the course so far. We're going to be seeing this when we make a mistake. When you try to do something that's not allowed, you just get this error. And where did it happen? Well, here, what's the name of the error? Array index out of bounds. So you have to keep in mind all of these indexes that you pass here have to be in bounds for that array. So for this one, the indexes are from 0 through 4. Which values are in the created array by default? You can see that, for example, by printing, let me just get rid of this. It's always a default value for the data type. And you remember we had a presentation a couple of classes ago, maybe about all the data types and all of their like default values. They're usually 0, 0.0 for doubles and so on. So all zeros for numerical types and false for the Boolean type. So look here, it's 0. When you don't set it to anything, for example, if we don't set array of 4 also to anything, they're going to be 0 and 0 here. Okay, 0 and 0. Okay, So let's do this one more time now with strings. For strings, that's a good question about the default values. Let's check it out. String is not a primitive data type, so we didn't actually see it a primitive. Default value, because it's something different. Let's create this. Let's say names equals new int, not new int. That's why I'm not getting autocomplete, because I messed up the type. New string of what? Let's say we wanted 3 names, and we can do names of 0 equals Milan, names of 1 equals Luca. And now let's print all the names of 0, 1, 2. By the way, I'm using the shortcut Control D. I mean, if I always try to type as little as I can. I use the shortcut Control D to duplicate the line, and then like just move with my arrows to change the index. Okay, let's run this and let's check out the default value for the strings. It's called a special value called null. We will learn, of course, more about null once we reach let's say, I don't know, another 2 or 3 classes, maybe, when we learn object-oriented concepts and objects and classes and so on. But for now, just know that null is your default value for the string. That's not a word null, that's a value null, like so. You can compare it. You can say if something is not equal to null, which means is not uninitialized, you can work with it. Because here, if, for example, you try to do names of 0.length, that will work, but names of 3.length won't work, because you cannot call methods on nulls. This is going to be another example, another exception, for example. You can see here exception on this line, calling null.length is not allowed, So keep that in mind, but we will of course come back to that a little bit later as well. So this is how you declare an array, this is how you fill up an array, this is how you access the elements of the array. Is that clear now? You can basically save as many values as you want, but you have to specify at the start how many do you want. This is one of the huge disadvantages of arrays, and in some of the later lessons, we're going to learn how to basically avoid that disadvantage and create something better and so on. So for now, let me see what I've covered from these slides. Not much here. Basically, this is just a visual representation, and it's a good representation to keep in your heads, because arrays are actually stored like this in memory. Let's not assume that it's always the memory locations are going to be like 500, 501. They can be like 500, 500, and it depends how many memory locations or bytes or bits does it take to store that actual value. But basically, arrays are always going to be stored in memory next to each other. Like all the numbers are going to be next to each other, so that's going to allow you to easily access them. And we will again come back to that once we are learning some more complex things like algorithm complexity and whatnot. By the end of this first module, I'll come back to this. But for now, all that you need to know is that arrays are, let's say when you're declaring something like this to Java, it says, okay, you need 5 integers. Let's say each integer takes 4 memory locations. So here you go, memory locations 1000, 1004, 1008, 1012, and 1016. So basically, once you ask for array of 3, it just immediately knows where to find it. It's only storing the start of the array. Let's say it's storing this 1000 here in the array variable, and we can even like verify that by printing the array. This value actually holds a reference or a memory location where the contents are. So let's check that out. If you just print array like this, let's see what we get. We get a thing called I something at, and this is its actual memory location, just written in hexadecimal. If you don't believe me, these letters A, B, C, D, E, F are used to represent numbers in a hexadecimal numbering system, which I'll also tell you about in some later lessons. But this is basically a numbered location where the start of this array is, And based on this location, it'll just add, let's say, 4 or 8 or 12 to find the second, third, or so on element. So basically, it can immediately, by just knowing the index of the element, it can access it immediately. That's the huge advantage of arrays, because they're really fast to access an element at an index. We'll see later what lists are better at, but this is just the advantage for arrays for sure. Okay, and this is what it says here. It's only storing the memory location in the format of a hexadecimal number, and this is G3. Here it's shown as a matrix, but usually here you will just see a memory location in the hexadecimal number. Here it's just for your visual representation. You know, oh, it's exactly there, and all the elements are next to each other, and these are their values. So yeah. Of course, now let's just use these arrays how they're meant to be used. Of course, you're never gonna like print 5 elements like this, nor are you gonna print 3 elements like this. You are actually just going to replace this with a for loop. How would that for loop look? You can also do a while loop. We said for loops and while loops are completely interchangeable, but it's the best to use a for loop because you have built-in index, that I variable. So you just type for, and you can write it out manually, int I equals 0, and then I less than array.length and so on. But it's much easier if you just remember the good shortcut for I. You just type for I, hit enter, and you get the whole body of the loop pre-built for you. You hit enter, you'd say, what's the condition here? Array.length, here it is. Hit one more enter, and you're here. And this is the most basic way to use a for loop and an array together. So what do? You start off, this is your variable that's going to go through all the indexes. Instead of printing 0, 1, 2, 3, 4, we're just going to use I to loop through 0, 1, 2, 3, 4. Why do we not include array length? Because this would produce an index out of bounds exception. Let me show you. If I was to print array of I here, this would produce an index out of bounds because you cannot include 5. Because 5 is the length, yes, but I being 5 means you want the 6th element, because the 0th element was the first one, actually. You know, index 0 gives you the first element, index length -1 gives you the last one. So keep that in mind. Here you can see it prints the first, second, third, fourth, fifth, and here when it tries to get the 6th, with I being 5, it will fail. So you have to put less than here, or use equals to array length -1. Both are fine, but it's just simpler to use this. I mean, it's less letters, so programmers always would prefer this way. So basically, I starts off with 0, goes up to array length, but not include array length because that one doesn't exist. So just go up to array length, but not including it, increase I by 1, and print out the element. And this is going to do the same thing that we've done manually, like here. And we're just going to do it in a loop. So we can process all the elements with for loops in the easiest way. I mean, we could, of course, go ahead and create like index equals 0, while, let's do a while loop for the name, to show you. I mean, you can always use a loop. While index less than names.length, for example, what do? You print out names of index plus plus, so increase index by 1. This is literally the same code. It's just, you know, that these two things are integrated here. This is integrated into the if, into the for, and this also thing from the end is integrated into the end of the for loop. So basically you could just get one single line, and that's why you'll most often see for loops for this kind of thing when you need the index. And of course, now you just print all the names down here as well. Works just the same. One question for you guys is, could this also work? Will this work properly? Names of index plus plus, and then that's the only thing. Okay, let's run to verify. Katerina is right. It will work. It just prints them all. And what about plus plus index? Does this work? No. Do you mind elaborating why? Because that's again correct. I really like how you're thinking. Can you write in the short word, I mean, just in a couple of words, why do you think this will not work? And it actually won't. It will seem to work, but it will crash because of the pre-increment, right? You notice that really well. Yeah, the pre, first of all, it skips the first word. That's bug number 1. So it skips the first word, so that's bad, right? And it also crashes, so that's bug number 2. I mean, even if it didn't crash, it skips my name Milan, you know, at 0th position. Why? Because index starts off at 0, and then here we're saying plus plus that 0, but first increase it and then take the index of that. And in the other version, we were doing it properly. We were saying, hey, first take the name of 0 and then increase this to 1, you know. So that's why it was skipping the first name, and also why first increasing it will take it to 2. When it's 2, it's supposed to give you that element, but you're going to increase it to 3 and it'll crash. So you have to increase after getting the element, which is why post increment will just work here. And I'm going to leave it like so you guys, I mean, are familiar with this way of writing it as well. Okay, do we have any questions about, let's say, these basic operations with arrays? What will happen if we try to make string name3 name1 plus name2 and print name3? Let's do that here. Names of 3 equals names of 0 plus names of 1. I'll answer your question, Katarina, as well. Here it will crash because there is no names of 3. There's only names of 2. But if you want to do names of 2, let's get rid of this. Now we're printing them via the loop. If you want to do this will work. It'll say Milan Luka, you know. And let's get rid of this name 0.length. Let's just print all the names. And you can see now Milan Luka and Milan Luka. Of course, if you were asking, for example, let's put a fourth name, and now let's leave the second one uninitialized, and let's say name3 equals names of 0 plus names of 2, because names of 2 will be null. Now let's check it out. What will it do? What do you think? It will not crash, because we're not actually doing anything with this null value. We're just adding it to a string. So yeah, it will just display itself as a null, string called null. So basically it will not crash, but if you were calling a method on it, like, I don't know, topper to lowercase, for example, now this will just crash. Because you're trying to call a method on something that's null, and that's not allowed. And that's a great question, Dimitri. I mean, I took a little bit of liberty in understanding it and explaining this as well. I think you meant this, really, because you said name1 plus name2, and if we put that in another one, you know, so that's a great question. To answer it, Katerina, how can we increase the size of the array? Well, we cannot, and we also can. So to explain that fully, you really cannot. Once you cannot make this array have more memory here. Why? Because maybe something already exists at memory location 1020. That's just my speculation. I'm not 100% sure on this, but it would make sense to me that this piece of memory here might be occupied, or not 120, but let's say 150 is occupied, and you wanted to increase it by, I don't know, 20 elements. So yeah, this might not be yours to take. So instead of allowing you to take more memory there, it will actually, when you want this array to have more size, you can create another array somewhere else in memory, copy all the elements, and then add new elements to that array. That's kind of burdensome, I know, and that's what we will have to do in some of the later classes. Today, we're just going to work with static arrays, which don't change in size. But once we learn a little bit more, we will actually learn how to manually, and then also you first manually create a self-resizing array. Let's say an array which grows in size once you fill it up. We're going to create that, and afterwards we're going to be using the array list by Java, which is Java's implementation of that powerful array, let's say. So we will cover all that in the next couple of weeks, I would say. So I mean, stay tuned for that. For now, we will not be increasing the size of the array. We will always be working with the same size arrays that will just be filled up with some numbers or something, and then we will, you know, learn how to increase them in a later lesson, because arrays will take a little bit to explain fully and understand. So again, to reiterate, this is how you can declare a new array. Let's say array equals new integer of 10 or of 20, and you can go through an array usually with a for loop. I've shown you guys how you can do it with a while loop as well. It's quite easy, but I mean, for loops are just naturally meant for this kind of stuff. Int I or index or iterator, whatever you prefer, equals 0, always start from 0, always end, not including the length. Those are the only two things that you have to worry about. Increase by 1, and that's the whole story. So for the string array, similar story. We've seen it here with names. You just create a string, and then you say it's a string array, and then you say how many strings you want. You want 4 strings, and that's it. They will have the null default value, so keep that in mind. This is the only non-primitive array that we're going to be using thus far, so they can have the null value. So doing something like this will not work. So pay attention to that. I'll get rid of this to lowercase just so our program doesn't crash. Okay. Fast array and initialization. This is just a nicer way to do this. For example, I knew these numbers are going to be this, or I knew these names are going to be these names. So what you could do is I'm going to write a comment, fast array initialization. Okay, I spelled that correctly. You can do something like string employees and then equals, and then you can basically either do it with new int array. I mean, these words are not mandatory, new int and then array, and then you can specify all the elements here inside of brackets. Not int really, but new string, of course. New string array, and you can specify elements here in the brackets, separated by a comma. Milan, Marco, Linda, Luca. You can add as many as you want, but still, once you add these 4, you have initialized it with 4. You cannot really go back and say employees of 5. You can only use the 4. This is basically, once you know the values at the start, you can just hard code them like this in code, avoid doing like these 4 lines of assigning names, 1 per line. Also, this part is not really mandatory. You can also omit this, so you can just put the value of the array inside of the brackets. I think this was added in some Java because they found it obsolete. Because you can deduce the type of this is the array of strings by the types of the variables here. If I put 50 here, it's going to complain because now, it's going to only allow strings because you said the string array will be here. So this is just fast array initialization. We're going to be using this maybe to test our programs. For example, rather than asking the user for 20 inputs and them doing something, we're just going to hard code like 20 or 10 numbers to see, how to work with arrays. Or when for example, the values at the start, like for the months, how many days they will have. Let's say this is called months per day, days per month, sorry. What did I click? And you can basically say, okay, this is how many days the first one will have, second one, and so on. So you can hard code all the values. Same thing with the names. So here you can hard code all the string values. You can use this faster initialization, of course, with any type. And we will rarely, use this and manually fill it up. So